So we are now going to look at quiz 6, which is an optional quiz that was designed to help you understand what type of questions we could ask based on the material from week 10 through week 12. Now, here, these questions are purely based on the lecture notes. There are material that we covered in the course readings, like substitution with our inverse trig functions, as well as area between curves that you could have seen on Mathmatize, but those we'd have some leading information to help you with those types of questions on the exam. And in the mock exam, you'll see some question of those forms to help you understand how we could solve those questions given what we have. So let's take a look at this type of question. I have compute the antiderivative of 2x secant squared x squared. And when we compute an antiderivative, I actually find it easier to compute the indefinite integral. And then recall later that we're solving an antiderivative, not all possible. So here it's a u sub question, x squared du by dx equals 2x. 1 over 2x du by dx equals 1. Substituting this in, we get this equals 2x over 2x secant squared x squared du by dx, which equals secant u du by dx, because these cancel and the remaining x term can be replaced with u. This gives, secant squared u. This equals tan of u plus c. Again, I need to replace tan of u with x squared, so it's tan of x squared plus c. Now this would be the indefinite integral, all possible, but this was asking for an antiderivative. So we need to give a specific constant. We need to specify the constant. So it's not generic, it's a specific one. So the classic answer would be tan of x squared, where the constant's 0. But you could do anything you want, like tan of x squared plus pi to the power e. And that's perfectly fine, but you need to give a specific constant, not a generic constant. Second question, define the fundamental theorem of calculus 2. Well, if we let f be a continuous function over AB and f be an antiderivative of f, then the integral from a to b of f of x dx equals f of b minus f of a, which notationally is the same as f of x evaluated at x equals a to b. Next, we have a Riemann sum question. Now, this question asks us to compute the area under the curve or approximate the area under the curve using left-hand approximations with a three rectangles using a Riemann sum. What it's asking us to do is to build 3 rectangles to approximate this area. And I know these rectangles aren't perfect. But each of these rectangles are a right end approximation. So we use the right end of the interval. And here, the interval is length 0.4, 0.4, 0.4 long. My height is approximately 0.7. This height is approximately 0.8 or 0.9. And this height is approximately 1.1, let's say. I know this isn't great, but it's an approximation. And here, this is A1, A2, and A3. Now, if you were to show us this work, and then you would say A equals 0.4 times 0.7 plus 0.4 times 0.9 plus 0.4 times 1.1, we give you the marks because your approximation is reasonable. It's not perfect, but we see exactly what you're doing. You're doing a right end, you're taking those values. And as long as you do the rest of the calculations correct, we give you the marks. And here to do the rest of the calculations, we factor out the 0.4 times 0.7 plus 0.9 plus 1.1, which equals 0.4 times 2.7, which equals 2.7, 0.4 times 8 plus 2 is 10, so 1.08. So approximately 1.08. Depending on what value is used here, your approximation may be different. But because it's coming from a graph, that's okay. It's just a general approximation. You show you know the process, and showing your work, you get the mark.